Hi, you can see in this video that the sky is so clear in this region of our Earth's atmosphere. This is the view of the sky from 35,000 feet above the mean sea level, which is approximately 11 kilometers above the mean sea level. One can also observe clouds down below. Below those clouds is where much of the weather of the atmosphere occurs, near the Earth's surface, but not so much right at this place where the sky is so clear. Right here at 11 kilometers above the sea level, it not only looks clear but also looks warm. It is not as warm as the place where the weather occurs. Because of the sight of the sun rays, it does look warm. One characteristic of this entire vertical region, which extends from about 10 kilometers to 50 kilometers, is that the temperature increases as one keeps going vertically above in this region. This region is called stratosphere. And the region below where much of the weather of the earth occurs is called troposphere. A little above from where the plane is presently flying, there are certain molecules that are shielding the earth from the harmful radiation emitted by the sun. The majority of the radiation emitted by the sun is in visible region, but there is also a kind of radiation which is not visible and highly energetic. And this high energy radiation, called the ultraviolet radiation, if it comes in contact with the human skin, is harmful for it. As I told you, there are gases a little above from where the plane is flying, in a region from 15 kilometers to 35 kilometers height from the Earth's surface. These gases are able to shield the Earth from the effect of the harmful ultraviolet radiations. In this video, I will not only talk about how they're able to shield the Earth from the ultraviolet radiations, but also how their presence is able to keep the stratosphere so clear. These molecules that protect the human beings from the harmful ultraviolet rays are called ozone molecules. These are gas molecules, pale blue in color and having a pungent odor. 90% of the ozone molecules are present in the stratosphere. The majority of them are at a height of 15 to 35 kilometers above the Earth's surface, and 10% of them are in the troposphere near the Earth's surface. And the region in the stratosphere where one would find majority of the ozone is a layer called the ozone layer. Though majority of the ozone molecules exist in the ozone layer, there are only about 1,000 ozone molecules of billion air molecules in this region. And therefore the thickness of the ozone layer is only 3 millimeters. And despite the lower concentration of the ozone molecules, they're highly effective in absorbing the ultraviolet rays and not allowing the high energy ultraviolet rays to reach the surface of the earth. The ultraviolet rays are of three categories, and the one having the highest energy is called UV ultraviolet C, and it is these rays that the ozone molecules are able to absorb most of the times. The UVA and the UVB are of lower energy than the UVC, and the entire UVA passes through the ozone layer and reaches the Earth's surface, and some of UVB also reaches the Earth's surface. The more dangerous UVC is kept away from the Earth's surface. And now let us see how the ozone molecule is able to keep away the UVC. Ozone molecule is 3 atoms of oxygen bounded together. Firstly, they have to be formed to even form a layer in the stratosphere. There are a lot of oxygen molecules, that is 2 atoms of oxygen bound together in the stratosphere. The oxygen molecules form 21% of the entire atmosphere of the Earth. The ultraviolet rays strike the oxygen molecule in the stratosphere at the specified height between 15 to 35 kilometers from the Earth's surface and break the oxygen molecule into 2 oxygen atoms. The wavelength of the ultraviolet radiation that splits the oxygen molecules is around 240 nanometers, very small wavelength, and hence their high energy, as the wavelength is inversely proportional to the energy of the electromagnetic radiation. After the oxygen molecule splits into 2 individual oxygen atoms, then each oxygen atom combines with the oxygen molecule and forms a molecule of ozone, 3 oxygen atoms bound together. The ultraviolet radiation of a slightly lower energy, that is having a wavelength of about 300 nanometers, in the case where oxygen molecule was split up, the wavelength was about 240 nanometers, here it is around 300 nanometers. But the present radiation also has a high energy. Despite that, this ultraviolet radiation strikes a molecule of ozone and splits it up into a molecule of oxygen and an atom of oxygen, and also there is a release of heat due to the split up of the ozone molecule. In this way, what is happening is the high energy UVC ultraviolet radiation is getting itself consumed in the process of splitting the ozone molecule, and its energy has gone to split up the ozone molecule as well as to release heat. This way, the decomposition of the ozone molecule is able to use up the high energy ultraviolet radiation, the UVC, and prevents the high energy radiation from reaching the Earth's surface. In the process, what's really happening is the ozone molecule itself is getting destroyed, but once it is destroyed, it also gets replenished, because a molecule of oxygen which is formed during the split up of the ozone molecule gets split up by the high energy ultraviolet radiation, given two oxygen atoms, and these oxygen atoms, each of them react with the oxygen molecule to again form the ozone. The ozone can also be formed if the oxygen atom that is produced when the ozone is split up reacts with a molecule of oxygen directly. In this way, the ozone itself gets replenished, and once it's replenished, it also gets destroyed to ensure that the high energy radiations get consumed and not reach the Earth's surface. The ozone molecule can be destroyed in other ways also, but here I'm focusing on the explanation that is relevant to the present topic of ultraviolet radiations. One can also personify the high energy ultraviolet radiations as a villain and the ozone molecule as a hero, and relate them to a certain dialogues from two South Indian movies. One is a Telugu movie called Bimla Nayak, another is a Tamil movie called Jailer. Let me first talk about the dialogue from the Tamil movie Jailer. The hero in this movie is Rajnikant. His name in the movie is Pandian. A Pandian in this movie protects his family from a villain. A villain threatens a Pandian that despite Pandian having protected his family, the villain would keep attempting to kill his family and would not stop the attempts until he reached his goal. I would like to tell the dialogue in Hindi as well as Malayalam. In Hindi, the dialogue goes like this. The villain speaks this dialogue to a Pandian. The villain tells Pandian, "बचा लिया ना? कितनी बार बचाएगा? 2 बार? 10 बार? 100 बार बचाएगा तू? अय, मैं 1000 बार कोशिश करूँगा." In Malayalam, the dialogue goes like this. The villain tells a Pandian, "താൻ രക്ഷിച്ചല്ലേ? എത്ര പ്രാവശ്യം രക്ഷിക്കും? 2 പ്രാവശ്യം? 10 പ്രാവശ്യം? 100 പ്രാവശ്യം രക്ഷിക്കോ നീ? ഏയ്, ഞാൻ 1000 പ്രാവശ്യം ശ്രമിക്കും." This is what the villain tells Pandian. From these two dialogues, one can personify the ultraviolet rays to tell this dialogue to the ozone molecules, because the ultraviolet rays relentlessly and persistently try to come towards the Earth's surface. In a similar light, the ozone molecules can also be personified, and here I would like to personify them as a hero from a Telugu movie called Bimla Nayak. The hero in this movie is Pawan Kalyan, and the name of the hero in the movie is Bimla Nayak. Bimla Nayak has an adversary. The adversary keeps troubling him. In a certain section of the movie, Bimla Nayak is traveling in a bus. The adversary is also sitting opposite him. Bimla Nayak tells a dialogue to his adversary, and the dialogue in Telugu goes like this. "నువ్వు పీకే నేను మళ్ళీ మొలుస్తా, నువ్వు తొక్కే నేను మళ్ళీ లెగుస్తా, నువ్వు తీసే నేను మళ్ళీ వస్తా, నీకు ఆపలేని యుద్ధం ఇది." So from in this dialogue, if ozone is personified as Bimla Nayak, the ozone gets destroyed by the ultraviolet rays, but at the same time it gets created again and again and again, relentlessly, persistently, to ensure that a high energy ultraviolet rays do not reach the Earth's surface. So basically, when viewed from a plane, which I am viewing in the video, there is a war that is persistently, relentlessly happening at a region higher than where the plane is right now, in between 15 kilometers to 35 kilometers. It is another matter that the ozone molecules are getting destroyed by a few chemicals injected into this region by human activities. I will probably talk about them in a different video.